औज़ुबिल्लाहि मिनश्शैतानिर्रजीम बिस्मिल्लाहिर्रहमानिर्रहीम रब्बि इश्रह ली सदरी व यस्सिर ली अमरी वहलुल उक़दतम मिन लिसानी यफ़क़हू क़ौली अल्लाहुम्मा अफ़्तह अलीना हिकमतक वंशुर अलैना रहमतक या ज़ल जलाली वल इकराम अल्लाहुम्मा इन्नी असअलुका इल्मन नाफ़िअन व अमलन मुतक़ब्बलन व रिज़्क़न तय्यिबा अल्लाहुम्मा आफ़िनी फ़ी बदनी अल्लाहुम्मा आफ़िनी फ़ी समई अल्लाहुम्मा आफ़िनी फ़ी बसरी ला इलाहा इल्ला अंता सुब्हानका इन्नी कुन्तु मिनज़ ज़ालिमीन हस्बुनल्लाहु व नि'मल वकील हस्बुनल्लाहु व नि'मल वकील हस्बुनल्लाहु व नि'मल वकील. Okay, assalamu alaikum everyone. So let's take a start. We have started this data transmission and types of data transmission. We have thoroughly discussed what is meant by data transmission in our previous tutorial. You can find this in the description box, the link of that tutorial. Okay, we have discussed in this chapter earlier what is data, what are packets, what is difference between data and packet, what is the purpose of converting the data into small chunks or packets or datagram, and what is the size of that packet, which is 64 KB. And before transmitting your data, like we are already transmitting right now sound data, audio data we are sending. I'm sharing this screen with you guys. So we are sharing different type of data, multimedia or audio, video, blah blah blah. We need to convert it before going to transmit it from sender to receiver. I am sender and you at this time your system is acting like a receiver. So we will convert the system will convert the data into small packets, manageable packet, which is 64 KB. So that we can easily manage it. The only disadvantage of data packet is that you need to reassemble the data at the destination end. That's it. This is all about data transmission, data packet. Okay, why do we need to convert the data into small manageable chunks, and what is the size of that data? Okay, now let's quickly revise this packet structure. We will convert the data into small chunks, and which is that its size is 64 KB. Now, so let's check what we have inside that header packet structure. So our typical packet is split up into three parts. First is header, the second one is payload, the third one is trailer. So in header contain IP address of sender, IP address of receiver, sequence of number of packets, because we convert the data into small chunks, and it has some specific sequence, because if we don't send the data or reassemble the data at the destination and correct order, so it is that data is useless for us. So sequence of number of packet allow correct reassembly at the destination, and is very important. The fourth part is size of packet in bytes. What is the size of that packet? 64 KB. Now in payloader, our actual data is loaded in payloader. Actual data, which is in 64 KB. Here is the size of the packet. Here is actual data is loaded in the payloader. The third is trailer. In trailer, we are having method of identifying of the end of packet. There are different methods to identify the end of packet. Why we will use this method identifying the end of packet? So that we can separate each data from the other data to reassemble correctly at the destination, and some form of error checking to ensure packet arrives error free. This is very important, to ensure that data arrive at the destination without any error. Okay, now so here is the description of packet structure. So IP address of sender, this is part of header. IP address of sender, sending device, IP address of receiving device, sequence of number of packet. This is ensure that all packets can be reassembled into the correct order once they reach the destination. That's why this is third point. Fourth point is packet size. This is ensure that receiving station can check if all of the packet have arrived intact. This one. Okay, now packet size. Your packet size. Okay. Now note the header often also contain another value, indicating how many packets there are in total for the transmission. In payloader consists of actual data being sent in packets 564 KB. Each packet in the packet trailer consists of the third one, the last one here, packet trailer. Some ways of identifying end of packet. This is essential to allow each packet to be separated from each other. This is very important. Identifying end of packet. The reason is this allows each packet to be separated from each other. That's why we identify the end of packet, so that we can separate each packet from each other. As they travel from sending to receiving station, we will discuss in packet switching in our next topic. Here is sending to receiving station. This is let's say client or server. This is computer A and this is computer B. This is sending station and this is receiving station. Okay. So now what's the next point over here? An error checking method. Cyclic redundancy check CRC is used to check the data packet. This is our last point over here. Some form of error checking method. So how to apply this? This involves the sending computer adding up all 1 bits in payload and storing this as a hexa value in the trailer before it is sent. Before going to transmit this data, we need to add all 1 bits together and store as a hexa value before we will send the data. Once the packet arrives, the receiving computer recalculates the number of 1 bits in the payloader. When data will arrive at the destination and we need to recalculate it, the number of 1 bits in the payload. This is called what? Cyclic redundancy check. The computer then checks that this value is against the one sent in the trailer. If the two values match, then no transmission error have occurred. Otherwise, the packet need to resend. Is there any question related to packet structure? If you have a question related to packet structure, you can ask now, or related to DataPacket or Datagram, because we are moving toward the next topic, which is our packet switching. Any question, class?
No, sir.
Good. Okay, now moving towards packet switching, this is next very important topic. Let us consider what happens when the photograph, for example, is sent from computer A to B. We are going to send photograph from computer A to computer B. So here we are going to send a photograph, transmit the photograph. Let's transmit this photograph from computer A to computer B. So here is computer B. So here is a router. Router will select the best possible route from where you can send your data. Like now from 15 August onward, you have to visit school and you have to select the best possible route for your new campus. Isn't it? From Bone Road or from Talagang Road. That suits you well, isn't it? Okay, no, that's called router. Router will set the destination, and these are different routes here. R2, R1, R5, these are different network of different routes, and here is router B, and then you will receive your data finally at the station B. So what's written over here? The photograph will be split up into number of packets before it is sent. We've already learned this in our DataGram or in DataPacket topic. Before going to transmit any information, any data, image, video, text file, we need to convert it into small chunks. That is called DataGram. The photograph will be split up into number of packets before it is sent. There will be several possible routes. These are several possible routes for the packet between computer A to computer B. A sender, computer A is sender, and computer B is receiver. Each stage in the router contains the root contains the router. Our router receives the data packet. Router will receive data packets. So this will receive data packets. Data packets and DatagGram are same. The size is 64 KB. So now router contains data packets. A router receives a data packet, and based on the information in the header of this data packet, decides where to send it to next. आपने काम सेट है. It can hold a data packet, hold the address, IP address of sender and IP address of receiver, so that it will deliver the data its correct destination. So now, for example, they have given a scenario here. Packet switching is a method of data transmission in which a message is broken up into number of packets. Okay, now packet switching is a method of data transmission in which message is broken up into a number of packets. Each packet can then be sent independently from start point to end point. From this is start point, computer A start point, and this is end point. At the destination, the packet needs to be destination. Where is the destination? Computer B is the destination. The packet will need to be reassembled. This is the only disadvantage of converting data into data packets, because you need to reassemble it at the destination and in their correct order using the information sent in the header. At each stage, the transmission, there are nodes that contain a router. Each router will determine which route the packet needs to take in order to reach its destination. Destination is IP address is used in this part of the process. Destination. Suppose our photograph has been split up into 5 packets. Photograph is split into how many packets? 5 packets that have been sent in the following order. So order is over here. We will check that. Here is, look here, the photograph is converted into these small manageable packets with these different colors, and these different colors will take different routes. So now look here, first data we are sending from router A, the red one take this route R2, then it will take R5 route, then it will move towards the router 8, then this one move towards router 7, then router 4, then it will reach to this destination. So now next packet, this color, so this one is brown color, it will take R6, then R5, then R8, then R9, router 9, then router 10, and then final the router B, which is called different, and these are different nodes over here. These are known as nodes. And here is your router A and router B, and your data will reassemble at the destination and correct order over here. So let's say green packet. This is your picture. Your picture is converted into these packets. Photograph chunks into small chunks known as what? Datagram, or we say data packet. And its size is 64 KB. So this information is over here, this one. Your image photograph is split into small chunks. These are small chunks, and it will take different routes to send the data towards the destination. And here we need to reassemble this data in correct order. Because the information is in the data packet, which is we have already learned in data structure what kind of information is stored in data packet, which is header. In data packet we have header, we have payload, and we have the trailer as well, and they have different information stored in it, which will reassemble the data at the destination end. So now here are the few points here. Okay, now each packet will follow its own path. Route, yes, we have already experienced over here. Green will follow this path. It's not necessary it will follow this path. Algorithm will decide. It will always necessary to take the shortest possible path, but it is not always necessary to take the shortest possible path, because the reason is maybe the shortest path is busy, offline, then faulty, then it will take the separate route. Router will determine the route of each packet. Routing selection, router will determine the route for each packet. This is router. Okay, now the shortest possible path available is always selected. The shortest possible path, it's always selected. Shortest possible path which is available is always selected in this case. This may not always be shortest path that could be taken, since a certain part of the route may be too busy or not suitable. Unfortunately, packet can reach the destination in different orders. Unfortunately, packets can reach the destination in different orders. Then you need to reassemble that in which they are sent. So if they will not receive at the destination and correct data, we need to reassemble it. Okay, now show one possible scenario. Notice that different paths taken by each packet from computer A to computer B. Also notice that the packet have arrived in different order compared to where they were sent. Namely, look here. Computer A, B will now have the reassembled packets into original sequence. Computer will have to reassemble the packets into original sequence. This one, because computer A has sent this information in small packets, and it will take different routes to reach the destination, and here computer B now reassemble the data into correct order, so that you can manipulate and interpret that information. Now, benefit of packet switching. This is all about packet switching, because we are switching the information from different routes. Data transmission, packet switching. So now, what are the benefits of packet switching? There is no need to tie up a single communication line up. It is not necessary you will take only this route, this one, R2, R1, R3, R4, this one. You can take several routes to send your information at this destination. It is possible to overcome failed, busy or faulty lines by simply rerouting packets. Yes, if this line is busy, then you can do what? You can select go for this one. Then when you will go over here, reach over here, and you will realize this one is faulty, then you can reroute. You go back and you can take the another route. It is relatively easy to expand package usage. A high data transmission rate is possible. Drawbacks of packet switching includes packet can be lost and need to be resent. When packets are jumping from router A to router B, and then if some routes are not busy or not available, then it will bounce back again. So it will cause what? Data lost, and you need to resend that information again. The method is more prone to errors with real time streaming, for example, a live sporting event being transmitted over the internet. So it is not, it's the error prone when you are transmitting live sport. There is a delay in the destination while the packets are being reordered. Yes, delayed. These are different disadvantages of or drawbacks of packet switching, because when you are switching from router to router and taking different routes, there is a delay to receive the information at the destination, and maybe data lost during this process that you need to resend. Sometimes it is possible to for packets to get lost because they keep bouncing around from router to router and never actually reach their destination. Eventually, the network would just grind to a halt as the number of lost packets mount up, logging up to the system. To overcome this, a method called hopping is used. Hopping is when your data packet is jumping from computer A to computer B, and then from router A to router B, or for example, these different using their different routes, they are jumping back and forth. So that's called what? Hopping. To overcome this problem, we introduce a method over here that's called hopping. Is used. A hop number is added to the header of each packet, and this number is reduced by every time it leaves a router. It's just like a counter. For example, hop number is 10. Your data is right now at router number 3. Now it reached towards router number 5, then router number 8. Hopping is now reducing over here. You get decremented by 1. Router 11, router 15, router 21. Look here, our data is taking different routes and jumping from router A to router 11, router 11 to router 15, and router 15 to router number 21. And when it will move from leave one station to another, for example, one node to another, so hop number is decremented by 1. Hopping is not included on this syllabus, but included here for the completeness of to understand how packet can get lost. This is not part of your syllabus, but this is extra knowledge. Okay, sometimes students ask, what if the data is lost? Then we can how to recover that data. First process is we can resend the data. Another is a hopping method is used. A hop number is given a highest hop number, and then when it will reach one station, you can decrement it by 1. Each packet has a maximum hop number to start with. Once a hop number reaches 0, the packet hasn't reached its destination, then the packet is deleted, which when it reaches the next router, the missing packet will then be flagged by receiving computer, and request to resend these packets will be made. The packet is deleted from when hopping is reach 0, then data will be deleted from that computer or from that router, and then it will generate a flag and then request for this specific data you need to resend again. Any question? Because we have done with packet switching. Any question till here, class?
No, sir.
So this concept is clear, Amal?